Good morning, everybody. I wanted to remind some of you that have said your cameras are not working. There's been a whole lot of this going on. You need to bring your laptop by the school and ask for one of the tech people, Mrs. Maldonado, or any of the tech people. Mrs. Maldonado specifically had told me that y'all need to bring it to her. She has to re-image it, and then the camera will work. So anyway, that's what you need to do. You need to find some time to bring it by the school. And if you want to call first to make sure she's here, that's fine. But just you need to bring it up to school so they can fix that camera, okay? Because otherwise you won't be able to take pictures, and you need to take pictures. So anyway, just want to remind you guys about that because there's a whole bunch of you that are in that boat right now. Now posters. I want to remind you all the posters around the room. These are the Unit 2 posters. So these are the ones that talk about domain and range. Range are my Y numbers, and domain are my X numbers. Continuous and discrete. We're going to be talking more about that today. Discrete data, if you're looking at a graph, has dots. Or if it's a table and it's only got a few points on it, then you know when you graph it, it's just making a few dots. These are things that you count, things like tickets or dogs, or if you're doing a car wash, how many cars do you wash? You don't, sell a half a ticket, you sell a whole ticket. So these are things that are counted, tend to make discrete data. I don't want the half of a ticket or 3/4 of a ticket. I want, like a 1 ticket or 2 tickets or 3 tickets. So those things tend to be discrete data. Continuous, the ones that you make a line between the points, these are things that you measure. And measuring things would be like time, feet, seconds, degrees, anything like that. Those you tend to draw lines through them because you want all the little half of a second or 3/10 of a second or 0.82 seconds or whatever it may be for time and feet. Okay, so that's the difference between those two. We'll be talking about that today. And of course, remember your functions. If the X is repeat, it is not a function, right? So these are in the Unit 2 in your resources. Now, moving on around the room, some other things that we have been talking about. We have been talking about in linears, this lovely poster here with all the attributes, right? The x-intercept, y-intercept, where it crosses the y-axis, it's the y-intercept. Where it crosses the x-axis is the x-intercept. There are other names for x-intercept. Solution and 0 also mean x-intercept. So don't forget, all three of those mean the same thing. And of course, slope is when you count up and over to find slope. And other than that, that's all we're talking about slope right now. We'll be more concerned about slope when we get to Unit 3. And then the attributes of our quadratic. Of course, we have the vertex at the top or where it changes direction. If it goes up and comes down, at that point, that vertex is also known as a maximum. If it goes down and then come up like the one up in the corner, the little one up there, that where it changes direction is still a vertex, but now that's a minimum. Y-intercept is where it crosses the y-axis. The shape itself is called a parabola. Where it crosses the x-axis, those points are your x-intercepts and also known as solutions, also known as zeros. The imaginary line that splits it in half is your axis of symmetry. So those are the parts that you need to be able to recognize when you see a picture, right? Okay, so I want to make sure that you knew those posters were available. That particular quadratic poster is in Unit 7 posters. So again, under resources, I'm going to move resources to y'all's homepage, but for right now, for most of y'all, it's still under your, go to homepage and go to your classroom. And then after you click on the classroom, it'll have resources there as one of the options. Okay, so today's stuff. This is almost kind of like a review day. We're doing some mixed review. So the very first page of your worksheet is a little mixed review thing. So I'm going to talk about a couple of them. Number 10 is just finding the X and Y intercepts. They give you a picture. So just pick those out. Again, look at those posters if you're not sure what the X and Y intercepts are. On number 13, it's the second problem on the paper. I know it's numbered funny. But the number 13 says find the X and Y intercepts, but they give you an equation. So I'm thinking I need a picture. So how can I see a picture? Yes, you can put it in your calculator. For those of you at home, you're going to use the Desmos calculator. So go search on a new tab for Desmos calculator. Click on whatever link you find that says that, and it'll pop up with the Desmos calculator. It's got that little blank there. You type in the equation, and it will give you a little graph so you can see what it looks like. Now, those of us using the Inspire calculators, and this is all of you guys at home too, when you get to taking the STAR test, you cannot just type in that equation the way it looks there. The only way we can use the Inspire calculators is if it's in y equals format. So we need to take that equation and solve for y. Oh, which reminds me, there was a poster I went past over here. The poster I bypassed over here was also in Unit 3. So in Unit 3, I have a poster that specifically shows you how to solve one of those equations from going from standard format with 3x plus 2y equals 6 to y equals. So down here at the bottom, it is in y equals format, right? We start off by getting rid of the x term by undoing the add or subtract, and it's the whole 3x that goes away. When I get ready to rewrite it, this right-hand side, they are not like terms. So I rewrite them side by side, negative 3x plus 6. I bring down the 2y. How do I undo multiplying? You divide by 2, and then both pieces over here get divided by 2. Your final step is to reduce these fractions. So you just put the fraction in the calculator, negative 3 over 2, and see if it tells you it changed. If it doesn't change, it stays like that. 6 over 2 in the calculator, though, changes to a positive 3. So you just reduce your fractions for the final equation. This equation you can put in the Inspire calculator and then go look at the graph and the table and everything else. Okay, so that poster is in Unit 3 also. All right, so back to today's little review worksheet. So on that number 13, you will need to solve that one for y, just like that poster is showing you to do. Once you have it in y equals format, then you can put it in the calculator and then go look at the picture and pick out the x-intercept and the y-intercept. What are the zeros in 14? Again, they give you a picture. You should know from the vocab what a zero is. Again, look at poster unit number 7 if you need that. 11, evaluate. That's your plug and chug. That was on the function notation that we've been working on. So just really quickly on plug and chug. That's this one. Put this up a little bit bigger. I'll blow this up. Okay, so I've blown this up. F of 4. When you see F of 4, you should immediately think plug and chug. They are saying, find y when x is what number? See how the f of x is over here? What number did they plug in for the x? A 4. So all you're doing is taking the right-hand side over here and plugging in a 4. Remember, I say write it on your paper before you put it in the calculator, or even do it in your head. This is a negative 2. Where the x is, I make a parentheses. Right there where the x is, I made a parentheses, and it's being squared outside the parentheses. Plus 2x. Again, where the x is, I put a parentheses, and then minus 3. The parentheses are where the x's were. All you're doing is dropping a number in for the x, and the number they want you to drop in is a 4. So the 4 goes there, and the 4 goes there. You are just simplifying this right-hand side in the math screen of the calculator. Okay? You can also do it in your head if you want to, if you're careful with your positive and negative numbers. So if you just go put this in the calculator just like that and hit enter, it will tell you the answer. Now, if you're using a scientific calculator, that's a little trickier because you have to change the sign to negative after you put it in. But if you've got an Inspire calculator, it's pretty simple to do that. All right, so you can find that answer in there. It's a plug and chug vertex. Again, just picking out the ordered pair of that vertex in there. Again, it's a vocab word from Unit 7 poster. Let's see if there's anything else on here. Oh, and then what is the range down there in that last one? That's what we've been talking about the last few days. So range, is it the X numbers or the Y numbers? You might want to go look at that poster. On the back, okay, the back of that page, so the very next page, number 2. This is a whole list of things where you're going to write in your answer, whatever it is for your situation, how many pets you have, your weight. You can make up a weight. I don't care what your weight is. I don't need to see this. Number of desks in a room. So just to picture a room and just count however many desks you think are in there. Your shoe size, the number of girls in the room. Picture yourself in a schoolroom and just make a guess at how many girls or boys you think are in the room. So you're just answering these questions. The next column is, did you count that or did you measure that? Because if you counted it, would that be discrete data or continuous data? Well, if you remember my poster, discrete is the dots, D for discrete, D for dots. Those things are being counted. I count 1 ticket, 2 tickets, 3 tickets. I count 1 dog, 2 dogs, 3 dogs. Those are discrete data. I put dots on those. If it's things that I measure, like my weight or how fast I can run something or how many ounces are in a soda, then those are things that I measure, and those I want all the little fractions in between. I want to know that I ran it, not in just round it up to 10 seconds, or was I 10.01 or 10.123? Who won the race may go down to the thousandths of a second, right? So I want all the little numbers in between. So you're just going to go through that little exercise there. The only one that's really interesting on this is shoe size. So let's talk about that, Rose. I'm going to do one of these with you. Let's say, here's the worksheet. So again, you guys at home, you just need to put number 1, and you can just write your answer. You can say, did you count or measure, and then is it D or C for discrete or continuous? So the number of pets you have. I have 2 pets. Did I count them or I measure them? I count my pets. 1 pet, 2 pets, 3 pets. Is that discrete or continuous? That would be discrete. If I were going to go graph that, I would make dots and not connect the dots. I would leave it as discrete data on the graph. Your weight? Let's say I weigh 300 pounds. Is that measured or counted? You measure weight. Sometimes you want all the little fractions in between. Maybe you want to know if it's 300.1 or 300.2 or 300.3, whatever it may be. But this would be continuous. If you were to go graph something with a lot of weights and stuff on it, you would want all the little numbers in between the whole numbers. Number of desks, obviously that's counted, so that's going to be discrete. So you go on and do that. But I want to get to shoe size. My shoe size is 7.5. Okay? Now, did I count that or measure that? I'm not really sure. I mean, they measure your foot, but then when you go buy a shoe, can you buy a shoe? So I'm gonna leave that. I'm gonna put a question mark here because I'm really not sure if I counted or measured that. They measure your foot, but when you go buy a shoe, they either have like a size 6 or a 6.5, or a 7 or a 7.5, or an 8 or an 8.5. They come in whole sizes and half sizes. Could I buy a shoe that's 6.1 or 6.23? No, they don't have all those things. They only have these specific sizes. So I'm kind of thinking this would be more discreet because I can only buy a size 6 or a size 6.5 or a 7 or a 7.5. I can't buy all those little sizes in between. So to me, this would still be discreet simply because you only have certain sizes that you can buy. So when they say shoe size, that's one of those, and some of these are not absolute one way or the other. Sometimes depends on how I want to think about it and how I'm using that data. So it's not always cut and dry, but this is just a little exercise to help you identify whether something would be discrete or continuous if you're the person making the graph, if you're the person doing the research, right? Okay, so you just go fill out that little chart. It should only take you a few minutes. Don't stress too much over it. Other than if you count them, you know it's discrete. And if you measure something, then you know it's continuous. And if it's somewhere in between, it could go either way depending on how you think about it, okay? Worksheet number 3. This is what we were doing yesterday. So on this lovely worksheet, get rid of this old stuff up here. On this lovely worksheet, you are telling me, is it a function, yes or no? So remember, you just look at the x's, and if the x's repeat, it is not a function. If they give you a picture like these are, we use a vertical line test, not a horizontal line test, a vertical line test. And we take it across the graph, and it's only touching one point at a time, it is a function. If it's touching 2 points at a time, it is not a function, okay? So this one's gonna be no, this one's gonna be yes. Let's see, then ask you for the domain and range. So remember, just like yesterday, if these things are continuous, there are too many points to list in here. My domain are the x numbers. Ooh, that one's dried out. I might have the top line good. Here's my domain. It's the x numbers. I focus on the x numbers along this x-axis. I will look to see what's the furthest right, what's the furthest left. I kind of crop it. The furthest right it goes is 2. The furthest left it goes is -6. And this graph never goes to the right of 2, never goes to the left of 6. All these points in between here are between those two numbers. So x's are literally between those two numbers. So you put the x in the middle, you put the small number on the left, you put the bigger number on the right, and as long as you do that, you always point it left, and then you decide, do I need a line under it or not? So you look at the endpoints. If it's a solid endpoint, you put a line. Solid endpoint, put a line. Had one of these been an open circle like that, then you would not have put a line on that number. So remember the posters over here on Unit 1 that shows you the open circle and closed circle. Lines go with the closed in, filled in circles because they're equal to it. And if it's open circle, it's not equal to it, so you don't put a line under it. Range, do the same thing with the y numbers. What is the highest y number and what's the lowest y number? You crop it down. The highest up here is a 3. The lowest down here is a -6. So all these y's are between those two numbers. They never go above it, they never go below it. So I put my small number on the left side, put the y in the middle, because these are the ranges, the y numbers, and put the bigger number on the right. Turn the inequality pointed to the left, always point to the left as long as you got small numbers on the left and big numbers on the right. This one's got a solid circle down here with the -6, and up here, this one is solid. There's no open circle. They didn't do that. There's not an open circle up there, so this is also solid. Okay, so there's your, go ahead and give those a whirl. I've got the answer keys again for this so you can check your answers, but I'd like for you to try them first and then go check your answers to make sure that you're getting them right or wrong. And if something is not making sense to you and you have a question, email me, okay, and I will get with you. We'll try to have Zoom meetings, and whenever you need to after school, if you email me during the day and say, hey, can we Zoom after school today? Sure enough, I'll be there. We'll Zoom together, okay? Let's see, the last worksheet is a really simple one. It is just simply, and you've got a whole series of numbers down here. So on your paper, you can just write number 1 and write the answer yes or no. Is it a function or not? Yes or no function. And then is it discrete or continuous? Put D or C. So number 1, yes or no, and then either D or C. You just look at the picture. If it's dots, it is discrete. If it's got solid pieces of line or curve drawn around, then that's going to be continuous. If it's a mapping, is that just a mapping of like 3 individual points? So if all you know is it's 3 individual points on a graph, then it's discrete. Same thing if you just have a table there. You got a table of just a few points. That's just a few points on a graph, so that's going to be discrete. All right, so there is your work. This is just a review day, bringing it all together on what we've been studying so far. So if you have any questions, be sure and email me, right? And we'll get together hopefully soon, because I know some of you are coming back next 6 weeks, so I'm excited about that. Okay, y'all take care.